The universe stretches out before us, vast and mysterious. But what if everything we can see, everything we've ever observed, is just the tip of an unimaginable cosmic iceberg? The stars, galaxies, and even the farthest reaches of the observable cosmos might only be a tiny fraction of what's truly out there, beyond the limits of our telescopes, beyond the edges of what light can reach us, lies a realm that defies our understanding and challenges the very nature of reality. What could exist in that uncharted expanse? Could there be other universes, each with their own laws of physics, or infinite cosmic bubbles drifting in a sea of existence we can't yet comprehend? This isn't just about curiosity, it's about humanity's relentless drive to explore the unknown. The question of what lies beyond the observable universe isn't just a scientific puzzle. It's a profound journey into the heart of existence itself. In this video, we'll dive into the most fascinating theories that attempt to answer this question. From the multiverse to cosmic bubbles, from hidden dimensions to the very fabric of space-time, we'll explore ideas that stretch the limits of imagination. So, are you ready to venture beyond the known and into the infinite? Let's begin. Imagine standing in the middle of an endless foggy field. No matter how far you walk, the fog seems to stretch forever, hiding whatever lies beyond your line of sight. This is a bit like the observable universe, the portion of the cosmos we can see from Earth. But instead of fog, our vision is limited by two key factors: the speed of light and the age of the universe itself. Light travels fast, but it's not instantaneous, and the universe has only been around for about 13.8 billion years. That means the farthest light we can see has been traveling for that same amount of time. Anything beyond that distance, it's still on its way to us, hidden behind what we call the cosmic horizon. Now, think about that horizon. It's not a physical barrier, but rather a boundary created by the limits of time and space. Beyond it, there could be galaxies, stars, and maybe even civilizations we'll never know about, at least not with the tools and knowledge we have today. And within the observable universe, it's staggering. We're talking about hundreds of billions of galaxies, each packed with billions of stars, planets, and phenomena like black holes and nebulae. Then there's the cosmic microwave background radiation, the faint afterglow of the Big Bang, which gives us a glimpse of the universe when it was just a hot, dense soup of energy. It's like a cosmic snapshot from the very beginning of time. But here's the thing, as vast as the observable universe is, it's just a tiny fraction of what's out there. Astronomers and cosmologists believe the entire universe could be far larger, perhaps even infinite. So, if the observable universe is like the foggy field we can see, what lies beyond the horizon? Could there be other fields, other universes, or something entirely beyond our comprehension? That's the mystery that drives us to keep exploring, to push the boundaries of what we know and what we can imagine. The cosmic horizon is one of the most fascinating and mysterious boundaries in our universe. Think of it as a kind of cosmic curtain drawn across the vast expanse of space, marking the edge of what we can observe. But how does this horizon form, and why can't we see past it? The answer lies in the interplay between light, time, and the expansion of the universe itself. Light, after all, is our primary window into the cosmos. It carries information from distant stars, galaxies, and even the faint echoes of the Big Bang. But light doesn't travel infinitely fast, it moves at a speed of about 300,000 kilometers per second. That means the light we see today from distant objects left them long ago, sometimes billions of years in the past. Now, imagine a spaceship traveling at the speed of light, racing to the edge of the observable universe. No matter how far it goes, it would never catch up to the expanding boundary of the cosmic horizon. This is because space itself is stretching, carrying galaxies away from us faster than light can bridge the gap. What's more, the cosmic horizon isn't static, it's constantly expanding. As the universe grows, new light from previously unreachable regions eventually reaches us, slowly revealing more of the cosmos. But here's the catch: no matter how much time passes, there will always be regions of the universe whose light hasn't had enough time to reach us. These areas remain forever hidden, shrouded in mystery. This raises a tantalizing question: what lies beyond the cosmic horizon? Is it more of the same, endless galaxies, stars, and planets? Or could it be something entirely different, something beyond our current understanding? The truth is, we may never know for certain. The cosmic horizon isn't just a physical barrier, it's a reminder of the limits of human perception and the vastness of the unknown. But what if the universe is far larger and stranger than we can imagine? What if the observable universe is just a tiny fraction of a much grander cosmic landscape, filled with structures and phenomena we've yet to even dream of? This idea pushes the boundaries of our curiosity, inviting us to ponder the true scale and nature of existence itself. The Big Bang is often described as the moment when our universe burst into existence, but what exactly does that mean? Picture a single point of unimaginable density and heat, a singularity where all the matter and energy that would eventually form galaxies, stars, and even us was compressed into an infinitesimally small space. Then, in a fraction of a second, it expanded faster than the speed of light, a process known as cosmic inflation. This rapid expansion didn't just create space, it also laid the groundwork for the cosmic web of galaxies we see today. Think of it like blowing up a balloon covered in tiny dots. As the balloon expands, the dots move farther apart, but they're still connected by the surface of the balloon itself. In the same way, the Big Bang stretched the fabric of space-time, spreading matter and energy across vast distances while leaving behind a faint echo of that initial explosion, what we now detect as the cosmic microwave background radiation. This ancient light is like a snapshot of the universe in its infancy, offering us a glimpse into its earliest moments. But here's where things get even more intriguing. While the Big Bang is often thought of as the beginning of everything, some scientists suggest it might not be the only beginning. Could there have been other Big Bangs, each birthing a separate universe? Imagine a vast cosmic landscape, not just one universe, but a multiverse, a collection of countless universes, each with its own unique physical laws and dimensions. This idea challenges our understanding of existence, pushing us to consider whether our universe is just one bubble in an infinite cosmic foam. So, if the Big Bang was the spark that ignited our universe, what lies beyond it? Could there be other universes, perhaps even ones we'll never be able to observe or interact with? These questions take us to the edge of what we know, inviting us to explore not just the origins of our universe, but the very nature of reality itself. What if everything we see, everything we know, is just one tiny piece of an unimaginably vast puzzle? This is the heart of the multiverse theory, a mind-bending idea that suggests our universe might be just one of countless others, each with its own unique set of rules, histories, and realities. Think of it like bubbles in a cosmic foam, each bubble representing a separate universe floating in an endless sea of possibilities. Some of these bubbles might be nearly identical to ours, with only the slightest differences, while others could be so alien that they defy everything we think we know about physics, time, and existence. Within the multiverse framework, there are several fascinating variations. One of the most intriguing is the concept of bubble universes. Picture this: just as soap bubbles form and drift apart, entire universes could be born from the same cosmic fabric, expanding and evolving independently. These bubble universes might never touch or interact, yet they exist alongside each other, each one a self-contained reality. Then there are parallel realities where every decision you've ever made spawns a new universe. In one reality, you might be reading this script on a different device. In another, you might not even exist. The possibilities are as vast as they are bewildering. What makes the multiverse theory so captivating is how it challenges our understanding of reality itself. It forces us to confront the idea that our universe might not be the center of everything, but rather one small part of an infinite tapestry. And while this concept might sound like science fiction, it's rooted in serious scientific inquiry from quantum mechanics to cosmology. So, let's take a closer look at one of the most compelling ideas within the multiverse theory, bubble universes, and how they might hold the key to understanding the true nature of existence. Picture a vast cosmic sea filled with countless soap bubbles drifting and shimmering in the air. Each bubble is its own self-contained universe, floating alongside others in an infinite expanse. This is the fascinating idea behind bubble universes, a theory suggesting that our universe might just be one of many, each with its own unique set of physical laws. Some might have gravity stronger than ours, while others could have entirely different particles or forces we can't even imagine. The possibilities are as endless as the bubbles themselves. But how do these bubble universes come to be? Think of them as regions of space that spontaneously inflate, much like a bubble forming in a soapy solution. In the earliest moments of the cosmos, rapid expansion could have caused pockets of space to pinch off and grow independently, creating these separate universes. Each one would then evolve on its own, governed by its own rules, completely isolated from the others, at least for a time. Now, what happens when these bubbles collide? Just like soap bubbles bumping into each other, bubble universes might occasionally meet, creating ripples or imprints on one another. Scientists speculate that these collisions could leave behind detectable signatures, like distortions in the cosmic microwave background, the faint afterglow of the Big Bang. These traces could be our first clues to the existence of other universes, sparking excitement and curiosity among cosmologists. So, if bubble universes are out there, how do they interact? Do they simply drift past each other, or could they merge, creating entirely new cosmic structures? The answers to these questions could reshape our understanding of reality itself, offering a glimpse into a multiverse far grander and more mysterious than we ever imagined. One of the most fascinating theories about what lies beyond the observable universe is the idea of eternal inflation. Picture this: instead of a single cosmic event like the Big Bang being the starting point of everything, imagine the universe as a bubbling, ever-expanding sea. In this model, the fabric of space-time isn't just stretching. It's constantly giving birth to new regions, each one a self-contained universe with its own rules, physics, and possibilities. Think of it like a never-ending fireworks display, where every spark that bursts into the sky becomes its own dazzling light show, each one different from the last. This theory suggests that our universe might just be one of an infinite number of bubble universes, all floating in a vast cosmic foam. Each bubble could have its own unique properties. Some might have stronger gravity, others might have completely different fundamental forces, and some could even have dimensions we can't even imagine. The implications are staggering. It means that reality, as we know it, might be just one tiny sliver of an infinitely varied multiverse. What's even more mind-bending is how these universes might differ from our own. In some, the conditions could be so alien that life as we understand it might be impossible. In others, the laws of physics might allow for phenomena we've never even dreamed of. Eternal inflation opens up the possibility that our universe is just one version of reality, and that beyond it lies an endless array of others, each one a unique experiment in the grand cosmic laboratory. This idea doesn't just challenge our understanding of the cosmos, it redefines it. If eternal inflation is true, then the universe isn't just vast, it's inexhaustible, constantly creating new realms of existence. And while we may never be able to visit these other universes, the thought that they might exist out there, each one a completely different story, is enough to make you wonder, what else is out there waiting to be discovered? What if every decision you've ever made or could have made exists somewhere in a completely separate reality? This is the fascinating idea behind parallel universes, a concept that stretches the limits of our imagination. At its core, this theory suggests that every possible outcome of every event plays out in its own distinct universe. Think about something as simple as flipping a coin. In one universe, it lands on heads, in another, it's tails. But what if the coin never landed at all? In yet another universe, maybe it's still spinning in midair. The possibilities are endless, and each one branches off into its own reality. This idea isn't just science fiction, it's deeply rooted in the many worlds interpretation of quantum mechanics. According to this theory, every time a quantum event occurs, the universe splits into multiple versions of itself, each representing a different outcome. It's like a cosmic tree with infinite branches, where every choice, every chance, and every random event creates a new world. And while this might sound mind-bending, it's a legitimate scientific framework that challenges our understanding of reality. But what does this mean for us? If parallel universes exist, they raise profound philosophical questions. Are there versions of us living out every possible life we could have led? What might those lives look like? And perhaps most intriguingly, could we ever cross paths with these alternate realities? Scientists and thinkers have debated this for decades, and while there's no concrete evidence, yet the idea opens up a universe of possibilities, both literally and figuratively. So, if parallel universes are real, what would it mean to interact with them? Could we ever find a way to glimpse into another version of existence? What if everything we see, touch, and experience is just a tiny slice of a much larger reality? This is the bold claim at the heart of string theory, one of the most fascinating and complex ideas in modern physics. According to this theory, the universe isn't just made up of the three spatial dimensions we're familiar with: length, width, and height, but rather, it's woven from tiny, vibrating strings that exist in up to 10 or even 11 dimensions. These extra dimensions, though, aren't something we can easily perceive. They're thought to be compactified or curled up so tightly that they're hidden from our everyday experience. To visualize this, think of our universe as a sheet of paper. On its flat surface, we can only move forward, backward, left, or right 2 dimensions. But if you zoom in close enough, you might notice tiny loops or folds, almost like the microscopic texture of the paper. These loops represent the extra dimensions, so small and intricate that they escape our notice. Now, imagine that sheet of paper is just one layer in a vast stack, each layer representing a different universe or reality. This is where string theory connects to the multiverse, suggesting that our universe might be one of countless others, each with its own set of dimensions and physical laws. But what holds these layers together? Enter the concept of brains, short for membranes. In string theory, brains are multidimensional objects that exist within the higher dimensional space. Our universe could be a 3-dimensional brain floating in a higher dimensional cosmos, interacting with other brains in ways we can't yet fully understand. These interactions might even explain some of the deepest mysteries of the cosmos, like the nature of dark energy or the origins of the Big Bang itself. So, while string theory pushes the boundaries of our imagination, it also offers a tantalizing glimpse into the hidden layers of reality, layers that might hold the keys to understanding the true nature of existence. And as we explore these ideas further, we'll see how they challenge our perception of the cosmos and open up new possibilities for what lies beyond the observable universe. What if our universe is just one layer of a much larger cosmic structure? That's the idea behind brain cosmology, a theory that suggests our universe is a three-dimensional membrane, or brain, floating within a higher dimensional space. Think of it like a single sheet of paper drifting in a vast, unseen ocean of dimensions we can't perceive. According to this theory, there could be other brains out there, each potentially hosting its own universe, all coexisting in this higher dimensional realm. One of the most fascinating aspects of brain cosmology is how it might explain the Big Bang. Imagine two sheets of paper, each representing a brain floating toward each other and colliding. The energy from that collision could have sparked the explosive birth of our universe. This idea not only provides a potential origin story for the cosmos, but also ties directly into string theory, which suggests that everything in the universe is made up of tiny, vibrating strings existing in multiple dimensions. Brain cosmology bridges the gap between these two fields, offering a framework where the fundamental particles and forces we observe could be the result of interactions within these higher dimensions. It's a mind-bending concept, but it raises an even bigger question. If brains exist, what else might be lurking in those higher dimensions? Could there be other universes parallel to ours, just out of reach? The possibilities are as vast as the dimensions themselves. What if everything we see, touch, and experience is nothing more than an illusion, a projection of information from a hidden surface? This is the mind-bending idea at the heart of the holographic principle. It suggests that our three-dimensional universe, with its galaxies, stars, and planets, might actually be encoded on a two-dimensional surface, like a cosmic movie projected from a flat screen. Think of it this way: when you watch a film, the images on the screen appear three-dimensional, full of depth and movement, but in reality, they're just patterns of light and color on a flat surface. The holographic principle proposes that our universe might work in a similar way, a vivid, immersive experience emerging from something far simpler. This concept doesn't just challenge our understanding of space, it turns it on its head. If the universe is a hologram, then the three-dimensional world we perceive could be a kind of mirage, a projection of information stored on a boundary we can't see. One of the most fascinating implications of this idea ties back to black holes. When matter falls into a black hole, it doesn't just disappear. Its information is thought to be encoded on the black hole's event horizon, the point of no return. The holographic principle takes this a step further, suggesting that the entire universe might operate like a black hole's event horizon, with all the information about everything we know encoded on its surface. But what does this mean for us? If the universe is a hologram, it raises profound questions about the nature of reality itself. Are we, in some sense, living inside a vast cosmic projection? Could our perception of space and time be nothing more than a sophisticated illusion? These questions don't just belong to the realm of science fiction, they're at the forefront of modern physics, challenging us to rethink everything we thought we knew about the cosmos. And as we explore these ideas, we're left with one tantalizing thought. If reality is a hologram, what else might we be missing? Now, let's take a closer look at one of the most fascinating ideas in modern physics: quantum fluctuations and vacuum energy. These concepts might sound abstract, but they're at the very heart of how our universe behaves, and they might even hold the key to understanding what lies beyond it. Picture this: even in the emptiest regions of space, where it seems like nothing exists, there's actually a constant hum of activity. This is the so-called vacuum energy, a kind of background energy that fills the cosmos. It's not empty at all. It's teeming with tiny, random fluctuations that pop in and out of existence. To visualize this, think of a calm pond on a windless day. The surface might look perfectly still, but if you look closely, you'll notice tiny ripples forming and disappearing. These ripples are like quantum fluctuations, small, unpredictable changes that happen all the time, even when everything seems quiet. In the same way, the vacuum of space is alive with these fluctuations, and they can have profound effects on the universe. Now, here's where it gets really interesting. Some scientists believe that these fluctuations could be the seeds of new universes. Just like a ripple can grow into a wave, a tiny quantum fluctuation might, under the right conditions, expand into an entirely new cosmos. This idea is central to theories about the birth of our own universe. Perhaps it all began as a single, unimaginably small fluctuation in the fabric of space-time. But vacuum energy doesn't just play a role in the birth of universes, it also influences their growth and ultimate fate. This energy is thought to be the driving force behind the accelerating expansion of the universe, pushing galaxies apart faster and faster over time. If this continues, it could shape the destiny of everything we know, leading to a future where the cosmos becomes colder, darker, and more spread out. This brings us to an even more mind-bending possibility, the quantum multiverse. If quantum fluctuations can create new universes, then perhaps our universe is just one of countless others, each with its own unique properties and laws of physics. In this view, every possible outcome of every quantum event could exist somewhere in a vast, interconnected web of realities. It's a concept that challenges our understanding of existence itself and opens up infinite possibilities for what lies beyond the observable cosmos. What if every decision, every tiny quantum event, split reality into countless new universes? This is the mind-bending idea behind the quantum multiverse. Unlike the cosmic multiverse, which imagines separate universes born from the Big Bang or inflation, the quantum multiverse suggests that every time a quantum particle behaves unpredictably, the universe branches into multiple realities. It's a concept rooted in quantum mechanics, where particles don't have definite states until they're observed. Think of Schrödinger's famous cat, a thought experiment where a cat in a box is simultaneously alive and dead until someone opens the box to check. In the quantum multiverse, both outcomes happen, but in separate universes. One universe has a living cat and another has a dead one. This idea raises profound questions about free will and determinism. If every quantum event creates a new universe, are our choices truly ours, or are they just one thread in an infinite tapestry of possibilities? Some argue that the quantum multiverse suggests a kind of cosmic democracy. Every possible outcome exists somewhere. Others see it as a challenge to the notion of free will, since every decision we make might simply be one version of countless others playing out across the multiverse. Now imagine the scale of this idea. If every quantum event spawns a new universe, how many universes could there be? The number is so vast it defies comprehension. Every flicker of light, every electron's path, every thought you have, each could be the seed of an entirely new reality. The quantum multiverse isn't just a theory about the cosmos, it's a mirror reflecting the infinite complexity of existence itself. Imagine the universe as an intricate tapestry woven together by threads of space-time. Now, picture a cosmic string, a hypothetical one-dimensional defect, like a tear or a wrinkle in that fabric. These strings, if they exist, are thought to be remnants from the earliest moments of the cosmos, stretching across unimaginable distances. Some theories suggest they could act as cosmic shortcuts, connecting distant regions of space or even bridging entirely separate universes. It's as if the universe has its own hidden stitching, binding together the vast, unseen corners of existence. But how might these strings function? Think of them as cosmic highways where the rules of space-time are bent in extraordinary ways. If two strings were to cross or interact, they could theoretically create pathways, portals, if you will, that defy our understanding of distance and time. This isn't just science fiction, It's a genuine possibility grounded in the mathematics of theoretical physics. And while we haven't observed cosmic strings directly, their potential existence opens up thrilling questions about the structure of reality itself. Now, let's take this idea one step further. If cosmic strings are like threads in the cosmic tapestry, then wormholes could be thought of as the needle's eye, a gateway piercing through the fabric of space-time itself. Wormholes, or Einstein-Rosen bridges, are another fascinating concept that could allow travel between distant points or even entirely different universes. Unlike cosmic strings, which are hypothetical defects, wormholes emerge from the equations of general relativity, suggesting they might be real, albeit incredibly unstable and difficult to detect. The connection between cosmic strings and wormholes is particularly intriguing. Some theories propose that cosmic strings could stabilize wormholes, making them traversable. Imagine a scenario where a cosmic string loops around, creating the conditions for a wormhole to form and remain open. This could be the ultimate shortcut, a bridge not just across space but across dimensions. It's a mind-bending idea, but one that highlights just how interconnected these concepts are in our quest to understand what lies beyond the observable universe. So, whether it's through the threads of cosmic strings or the gateways of wormholes, the universe might hold secrets far stranger and more wondrous than we've ever imagined. These ideas challenge us to think beyond the limits of our current knowledge, inviting us to explore the infinite possibilities that could lie just beyond the edge of what we can see. Picture this: you're standing at the base of a towering mountain, and the only way to reach the other side is by climbing over its steep, treacherous slopes. But what if there was a tunnel carved straight through the mountain, offering a direct path to your destination? This is essentially the idea behind wormholes' theoretical shortcuts through the fabric of space-time that could connect two distant points in the universe or even bridge entirely different realities. Wormholes, often referred to as Einstein-Rosen bridges, are solutions to the equations of general relativity that suggest the existence of tunnels in space-time. These tunnels could, in theory, link regions of the cosmos that are light years apart, or even connect separate universes altogether. But while the concept sounds like something straight out of science fiction, the reality of traversing a wormhole is far from simple. One of the biggest challenges is their inherent instability. The moment a wormhole forms, it tends to collapse almost instantly under its own gravitational forces. To keep it open and stable, scientists propose the need for something called exotic matter, a hypothetical substance with negative energy density that could counteract the collapsing forces. The catch: exotic matter has never been observed, and its properties defy our current understanding of physics. Even if we could stabilize a wormhole, the journey through it would be anything but straightforward. The intense gravitational forces could tear apart anything that enters, and the passage itself might be fraught with unpredictable hazards. But let's assume for a moment that these challenges could be overcome. What would that mean for us? The implications are staggering. Wormholes could revolutionize space exploration, allowing us to traverse unimaginable distances in the blink of an eye. They could even open the door to interdimensional travel, offering a glimpse into entirely different universes with their own unique laws of physics. Imagine stepping through a portal and emerging in a reality where time flows backward or gravity behaves in ways we've never seen. So, if wormholes exist, could they truly serve as gateways to other universes? The answer lies somewhere between the realms of possibility and the limits of our imagination. While the idea is tantalizing, it also raises profound questions about the nature of reality and our place within it. What might we discover on the other side, and what would it mean for our understanding of existence itself? As we ponder these questions, one thing becomes clear. Wormholes aren't just a scientific curiosity, they're a window into the infinite possibilities of the cosmos. And who knows, perhaps one day the secrets of space-time will unlock pathways to realities we can barely dream of today. The universe as we know it is far more mysterious than meets the eye. In fact, the stars, galaxies, and planets we can observe make up only a tiny fraction of what's really out there. The majority, about 95% of the cosmos, is composed of two enigmatic forces, dark matter and dark energy. These invisible entities are the architects of the universe, shaping its structure and driving its expansion in ways we're only beginning to understand. Think of dark matter as the invisible scaffolding of the cosmos. Just as a building relies on a framework hidden beneath its walls to stay upright, the universe depends on dark matter to hold galaxies together. Without it, stars would fly apart, and the intricate web of galaxy clusters we see today would never have formed. It's a cosmic glue, unseen yet essential, weaving the fabric of the universe into the vast, interconnected tapestry we observe. But dark matter isn't the only player in this cosmic drama. There's also dark energy, an even more elusive force that's pushing the universe to expand at an accelerating rate. Imagine blowing up a balloon with tiny dots painted on its surface. As the balloon inflates, the dots move farther apart. Dark energy is like the breath filling that balloon, stretching the universe in every direction faster and faster over time. Together, these two forces, dark matter holding things together and dark energy pulling them apart, create the delicate balance that defines our cosmos. What's truly fascinating is how these forces might shape what lies beyond the observable universe. If dark matter and dark energy dominate the cosmos, could there be entire regions of space we can't see, filled with structures or phenomena we can't even imagine? Some scientists speculate that beyond the edges of our observable universe lies a dark universe, a vast expanse where these invisible forces reign supreme, shaping realities we may never fully comprehend. It's a humbling reminder of how much we still have to discover. As we ponder the role of dark matter and dark energy, we're left with a tantalizing question. What else might be out there, hidden in the shadows of the cosmos, waiting to be uncovered? Have you ever wondered if the universe we see is just the tip of the iceberg? What if there's an entire hidden realm, invisible to us, shaping the cosmos in ways we can't fully grasp? This is the idea behind the dark universe, a mysterious domain where dark matter and dark energy reign supreme. Think of it like this: if the observable universe is the visible part of an iceberg, then the dark universe is the massive, submerged portion beneath the surface, unseen but undeniably powerful. Dark matter, for instance, doesn't emit light or energy, yet it exerts a gravitational pull so strong that it holds galaxies together. Without it, stars would scatter, and the cosmic structures we know would simply fall apart. Dark energy, on the other hand, is even more elusive. It's the force driving the universe to expand at an accelerating rate, pushing galaxies apart like an invisible hand stretching the fabric of space itself. Together, these two components make up about 95% of the universe, leaving the ordinary matter we can see as just a tiny fraction of the whole picture. But here's the challenge: how do you study something you can't see or touch? Scientists rely on indirect evidence, like the way galaxies rotate or how light bends around massive objects, to infer the presence of dark matter. Dark energy is even trickier, detected only through its effects on the universe's expansion. It's like trying to understand the wind by watching the leaves it moves. Fascinating, but not exactly straightforward. So, what could this dark universe be hiding? Could it hold clues about the origins of the cosmos or the fate of everything we know? If it exists as current evidence suggests, then it's a frontier brimming with secrets waiting to be uncovered. The question isn't just whether we'll solve these mysteries, but how they might change our understanding of reality itself. What if the universe has a rhythm, a cosmic pulse that beats through eternity? This is the essence of cyclic cosmology, a theory proposing that the universe isn't just a one-time event but part of an infinite loop of expansion and contraction. Picture it like the universe's heartbeat, each beat representing a cycle where everything we know expands outward, only to eventually collapse back in on itself, culminating in a new Big Bang and the birth of a fresh universe. It's not just a single story, it's an endless series of cosmic chapters, each one beginning where the last one ended. In this model, the universe doesn't have a definitive end. Instead, it cycles through phases of growth and collapse, with each Big Bang marking the start of a new cosmic era. But what happens between these cycles? Some theories suggest a period of extreme density, where matter and energy are compressed into a state so intense that the laws of physics as we know them might break down. Others propose that the transition between cycles could leave behind echoes, subtle traces of the previous universe embedded in the fabric of the new one. The implications are profound. If the universe is cyclical, it means the end isn't truly an end but a reset. Stars, galaxies, and even life itself might arise again and again, each cycle offering a new canvas for existence. This raises fascinating questions. Could civilizations from past universes have left clues behind? Might the universe we see today hold remnants of its predecessors? Cyclic cosmology doesn't just challenge our understanding of time and space, it invites us to rethink the very nature of existence itself. So, if the universe is trapped in an eternal loop of creation and destruction, what happens in the moments between each cycle? Is there a pause, a moment of silence in the cosmic symphony? Or does everything dissolve into chaos before the next Big Bang ignites? These are the mysteries that keep scientists and dreamers alike pondering the infinite possibilities of what lies beyond the observable cosmos. What if the universe has an expiration date? One of the most intriguing possibilities is the idea of the Big Crunch, a theory suggesting that the expansion of the universe could one day reverse, pulling everything back into a single, dense point. Picture a rubber band stretched to its limit, only to snap back with immense force. In this scenario, galaxies, stars, and even the fabric of spacetime itself would collapse inward, returning to a state of infinite density, a singularity. It's a dramatic end to the cosmic story, but what if it's not the end at all? This is where the big bounce comes into play. Instead of the universe ending in a fiery collapse, some scientists propose that this contraction could trigger a new Big Bang, birthing a fresh universe. Imagine that same rubber band snapping back, only to stretch out again, starting the cycle anew. This idea forms the backbone of cyclic cosmology, a model where the universe experiences endless cycles of expansion and contraction, a cosmic heartbeat, if you will. It's a theory that offers a glimmer of hope against the idea of a finite, one-and-done universe, but not everyone is convinced. The Big Crunch and Big Bounce theories are hotly debated in the scientific community. For one, current observations suggest that the universe's expansion is accelerating, not slowing down, which makes the idea of a collapse seem less likely. Others argue that even if a collapse were possible, the physics of such an event are far from understood. What would happen to the laws of nature in that final, chaotic moment? Would they reset, or would something entirely new emerge? These questions lead us to an even bigger debate. Is our universe finite or infinite? If the Big Bounce is real, it could mean our universe is just one in an endless series, each with its own unique properties and possibilities. On the other hand, if the universe continues to expand forever, it might be the only one of its kind, destined to fade into cold, dark emptiness. Both ideas challenge our understanding of existence, pushing us to rethink what it means to be part of something so vast and mysterious. One of the most profound questions in cosmology is whether the universe is finite or infinite in size. It's a debate that has captivated scientists and thinkers for centuries, and even today we're still searching for definitive answers. On one hand, a finite universe suggests boundaries, a cosmos with edges, however distant, that we could theoretically reach. On the other, an infinite universe stretches beyond comprehension, an endless expanse without limits. Both ideas challenge our understanding of space, time, and existence itself. To grasp the concept, think of the universe as a piece of art. A finite universe might resemble a bounded painting with edges framing its contents. Everything within it is contained, measurable, and in theory, knowable. But an infinite universe, that's more like a never-ending tapestry woven with threads that stretch into eternity. No matter how far you look, there's always more to explore, more to unravel. This metaphor helps us visualize the scale of these possibilities, but the reality is far more complex. Scientifically, the question hinges on cosmic geometry, the shape of the universe itself. If the universe is flat or open with a specific curvature, it could very well be infinite. Observations from the cosmic microwave background radiation, the afterglow of the Big Bang, suggest that the universe is remarkably flat on large scales. This flatness is a clue, but not a definitive answer. Even if the universe appears flat, it could still be finite, like the surface of a sphere, a closed loop that seems endless from within. Then there's the philosophical side. If the universe is finite, what lies beyond its boundaries? Is it simply nothing, or does the concept of beyond even make sense? An infinite universe raises its own set of questions. What does it mean for reality to stretch endlessly? Could there be infinite versions of Earth, infinite copies of ourselves in an infinite cosmos? These aren't just thought experiments, they're challenges to our very understanding of existence. So, if the universe is infinite, what does that mean for its structure? Would it be uniform with the same laws of physics applying everywhere? Or could there be pockets of reality so different from our own that they're unrecognizable? The implications are as vast as the possibilities themselves. What if the universe isn't just an endless, formless void, but instead has a shape, a geometry that defines its very nature? The idea that the cosmos could have a specific shape might sound strange, but it's one of the most intriguing questions in cosmology. Scientists have proposed several possibilities: a flat universe, a spherical one, or even a saddle-shaped cosmos. Each of these shapes carries profound implications for how the universe behaves, how it might end, and even how it began. To grasp this, think of the universe as the surface of a balloon. If you inflate it, every point on the surface moves away from every other point, a simple analogy for how galaxies move apart as the universe expands. Now imagine this balloon could take different forms. A flat universe would be like an infinitely stretching sheet of paper where parallel lines stay parallel forever. A spherical universe, on the other hand, would curve back on itself like the surface of a globe. Travel far enough and you might end up where you started. Then there's the saddle-shaped universe, which curves in a way that parallel lines would eventually diverge, creating a hyperbolic geometry. But how do we even begin to figure out which of these shapes our universe might have? The answer lies in the cosmic microwave background, the faint afterglow of the Big Bang. Tiny fluctuations in this ancient light act like a cosmic fingerprint, revealing clues about the universe's geometry. If the universe is flat, these fluctuations would follow a specific pattern. If it's curved, the pattern would shift in ways we can measure. So far, observations suggest the universe is remarkably flat, but the mystery isn't entirely solved. Now, here's where things get even more mind-bending. Some theories propose that the universe might not be just flat, spherical, or saddle-shaped. It could be toroidal, shaped like a giant donut. In a toroidal universe, space would loop back on itself in all directions, creating a finite but boundless cosmos. It's a fascinating idea, and while it's still speculative, it challenges us to rethink what we know about the fabric of reality. Could the universe be a cosmic donut? The answer, much like the shape of the cosmos itself, remains tantalizingly out of reach for now. What if the universe weren't flat or spherical but shaped like a donut? This is the idea behind the toroidal universe, a concept that challenges our usual understanding of space and time. Imagine the cosmos as a giant cosmic donut, where space loops back on itself in a continuous, finite yet unbounded structure. In this model, if you were to travel in a straight line, you might eventually return to your starting point, just like moving around the surface of a donut. It's a mind-bending idea, but it opens up fascinating possibilities for how the universe could be structured. Think of it like a video game world that wraps around. If you move off one edge of the screen, you reappear on the opposite side. In a toroidal universe, space behaves similarly, except on a cosmic scale. This topology could mean that the universe has no edges, no center, and yet it's finite in size. It's a closed loop where the very fabric of reality folds back into itself. This could also explain why we don't see an edge of the universe when we look out into space. Instead, what we perceive as endless might just be a vast, looping expanse. But what would this mean for us? For one, it could change how we think about space travel. In a toroidal universe, a journey outward might eventually lead you back to where you started without ever encountering a boundary. And when it comes to observation, light itself might loop around the universe, creating the possibility of seeing multiple images of the same galaxy or star from different angles. It's a concept that could reshape our understanding of distance, time, and even the nature of reality itself. So, if the universe is toroidal, how would it affect our perception of reality? Would it challenge our sense of direction or even our understanding of infinity? The toroidal model invites us to rethink the very foundation of what we know or think we know about the cosmos. And as we continue to explore these ideas, we might find that the universe is far more interconnected and mysterious than we ever imagined. What if the universe as we know it has an expiration date? It's a question that has fascinated scientists and philosophers alike, and the answers are as mind-bending as they are varied. Let's dive into some of the most compelling theories about the ultimate fate of the cosmos. One possibility is the so-called heat death of the universe. Imagine a cup of hot coffee left on the counter. It slowly cools down, losing energy until it reaches the same temperature as the room. In the same way, the universe might continue expanding forever, spreading its energy so thin that stars burn out, galaxies drift apart, and everything fades into a cold, dark, and lifeless void. This is the heat death scenario where entropy, the measure of disorder, reaches its maximum and the universe becomes a vast, static expanse. But what if the universe doesn't just fade away quietly? Another theory suggests something far more dramatic, the Big Rip. Picture a balloon being inflated until it suddenly tears apart. In this scenario, dark energy, the mysterious force driving the universe's accelerated expansion, becomes so powerful that it overcomes even the forces holding galaxies, stars, and eventually atoms together. The universe would literally be ripped apart, tearing everything down to its most fundamental pieces. It's a cosmic catastrophe on a scale we can hardly fathom. These theories hinge on one critical factor: the behavior of dark energy. Is it constant or does it grow stronger over time? The answer could determine whether the universe ends with a whimper or a bang. And while these ideas are rooted in physics, they raise profound philosophical questions. If the universe is destined to end, what does that mean for our existence? Does it strip life of meaning, or does it make the present moment all the more precious? So, if the universe does meet its end, whether through heat death, the Big Rip, or another fate entirely, what comes next? Could there be something beyond the end, or is it truly the final curtain? These are questions that push the boundaries of both science and imagination. What if the end of our universe isn't really an end at all? Picture this: the cosmos as a vast book with each chapter telling the story of a universe. When one chapter closes, another begins, filled with different laws, new dimensions, or even realities we can't yet comprehend. This idea isn't just science fiction. It's a concept that challenges everything we think we know about time, space, and existence. Imagine a universe where time doesn't flow in a straight line but loops back on itself, creating endless cycles of birth, death, and rebirth. Or consider the possibility of parallel dimensions where countless versions of reality exist side by side, each with its own unique rules. These aren't just wild guesses, they're ideas that physicists and cosmologists are actively exploring, using both mathematics and imagination to push the boundaries of what's possible. But here's the thing: the more we try to understand what lies beyond the edge of our observable universe, the more we realize how limited our perspective is. Our tools, our equations, even our language, they're all built to describe the reality we know. What if there's something out there that defies description entirely? Something so alien, so incomprehensible, that it reshapes our very understanding of existence. This is where science and imagination intersect. On one hand, we have the precision of mathematics, the rigor of observation, and the careful testing of hypotheses. On the other, we have the boundless creativity of the human mind, daring to dream of realities beyond our own. Together, they form a powerful partnership, guiding us toward answers while reminding us of how much we have yet to discover. And as we ponder these questions, it's worth reflecting on our place in the cosmos. We're tiny, fleeting beings on a small planet in an unfathomably vast universe. Yet here we are, asking questions that reach beyond the stars. In a way, our curiosity is our greatest strength. It's what drives us to explore, to learn, and to imagine what might lie beyond the end of everything we know. In the grand tapestry of the cosmos, humanity occupies a tiny, almost imperceptible thread. Yet, despite our seemingly insignificant scale, our curiosity and determination to understand the universe have propelled us to remarkable heights. From ancient civilizations mapping the stars to modern telescopes peering billions of light years into space, our quest to uncover the mysteries beyond the observable cosmos is a testament to the resilience and ingenuity of the human spirit. Consider this: every discovery, every theory, every leap in understanding begins with a simple question. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." This sentiment captures the essence of our journey, an unyielding drive to explore, to question, and to seek answers. It's this very curiosity that has led us to ponder what lies beyond the edges of our observable universe, challenging us to push the boundaries of knowledge and imagination. Throughout history, humanity's place in the cosmos has been a source of both humility and inspiration. We've come to realize that, while we may be small in the grand scheme of things, our capacity to wonder and explore is boundless. Whether it's the search for parallel universes, the mysteries of dark matter, or the enigma of what lies beyond the cosmic horizon, these questions remind us of our shared desire to understand our place in the infinite. As we reflect on this journey, it's clear that the pursuit of knowledge is not just about finding answers, it's about embracing the unknown and daring to ask the questions that might never have simple solutions. This is what makes our exploration of the cosmos so profoundly human. It's not just about the science, it's about the stories, the dreams, and the connections we forge along the way. So, as we stand on the precipice of the unknown, let's celebrate the curiosity that drives us forward. The mysteries of the universe are vast, but so too is our determination to uncover them. And in that pursuit, we find not only answers but also a deeper understanding of ourselves and our place in this extraordinary cosmos. So, where does all of this leave us? From the mind-bending concept of the multiverse to the chilling possibilities of the big freeze or the big crunch, we've journeyed through some of the most profound ideas about what lies beyond the observable cosmos. These theories remind us that the universe is far more complex, more mysterious, and more expansive than we can ever fully comprehend. They challenge not only our scientific understanding but also our philosophical perspectives, forcing us to confront the very nature of reality itself. What's truly astonishing is how these ideas intertwine science with imagination. The multiverse suggests an infinite array of parallel realities, while theories about the end of the universe, whether it's a slow fade into darkness or a dramatic collapse, paint a picture of time itself as something finite, something with a beginning and perhaps an end. And yet, even as we grapple with these immense concepts, we're left with more questions than answers. What does it mean for us as tiny beings on a pale blue dot to exist in a universe so vast and unknowable? These theories aren't just abstract musings, they're invitations to think bigger, to explore deeper, and to embrace the wonder of the unknown. They remind us that science is a journey, not a destination, and that every discovery opens the door to new mysteries. As Carl Sagan once said, somewhere something incredible is waiting to be known. That's the essence of our cosmic quest, a never-ending pursuit of knowledge driven by curiosity and a desire to understand our place in the grand tapestry of existence. So, what do you think lies beyond the observable universe? Could there be other realities, other dimensions, or even other versions of ourselves? Share your thoughts in the comments below. We'd love to hear your ideas and continue this conversation. And if you're as captivated by the infinite possibilities of the cosmos as we are, don't forget to subscribe for more journeys into the unknown. Together, let's keep exploring the infinite.